Thanks so much, Raf. I think Raf has taken us through the how we position the product in the market. But maybe in the next few slides, we're going to look at how we position the product on site. So we realized we're talking to, installers who are also salespeople. So we thought it's great to cover the sales portion and also the technical portion. So after knowing how to position it in the market, definitely we need to know how to position it on site. So in the next few slides, we're going to look at that, what it is exactly and what it can do and what it cannot do. I think it's important now for the installers to know that. So this product, just to give a little bit of background, it's a Huawei product. Then Huawei are strong in telecommunications. So this actually, from the previous name, which is the eyesight power, it was for sites, for internet-based stations, for telecommunication booster stations. That's what the product was meant for originally, right? Then seeing that there's a great gap in the residential space, they then adapted the product to come now into the residential space, and it changed the name to a PowerMate. So now it's no longer the eyesight power, but it's called a PowerMate. That's the official name if you go to the Huawei portal and everywhere else, right? It's a Huawei product. Then if it's a Huawei product, what it means for the installer or for anyone now is no touch. You don't have any button there, no HMI. You don't need any protection boxes. So Huawei makes all their inverters, their products with inbuilt protection systems. So you don't need a fuse, you don't need an isolator, you don't need a surge protector. All that is inbuilt. We're gonna look at that maybe in the next few slides, right? Then we would like to define this as a semi-hybrid unit. It's a hybrid because it integrates 3 different sources of power. You can actually be able to supply your loads from grid, from your PV, it takes panels, then also from your battery. That makes it a hybrid. But it's a semi-hybrid because you can't feed back to grid. You can't also feed back to non-essentials. So it's UPS based, right? In a way, you can call it a UPS that can take panels. That's why it's a semi-hybrid. So it's important when you are sizing and you are actually installing it on site that you realize that whatever you put on the non-essentials, it will never benefit from your PV, right? But if you take, for an example, if you had a 5 kilowatt any other hybrid inverter and you have backed up the whole house, so that functionality you also get that from the eyesight power. If you are backing up the whole house, or if you put, let's say, your geyser and your oven or your stove on the non-essential and you are not worried, you are saying these two, I don't mind them not getting anything from the PV system and from the batteries. So it works perfectly okay in that. So you can't call it a UPS, it's still a hybrid inverter, semi-hybrid for that matter. You can't feed back to grid, you need to stress that, and you can't feed back to your non-essential loads. But if you size it properly and you just split your board and say these loads are non-essential loads, then they will never benefit from PV, but whatever is on the output, they need to benefit from PV. So it comes in stackable. So the top part is the inverter. I would want to repeat what Rafi has already covered, but just to add a little bit on that. So it's a 6 kVA operating at 0.833 power factor. Then that gives you a 5 kilowatt inverter. Then the batteries are 5 kilowatt module, 5 kilowatt hour module each, right? But it's a 0.5 C. So what it means now, from your 5 kilowatt hour, you can only be able to take 2.5 kilowatt in 8 give and go. So we strongly recommend that you have at least 2 batteries for you to get the maximum power out of it. If you've got 1 battery, though you've got a 5 kilowatt inverter, you can only take 2.5 kilowatt. So you install it on a system, then the client is calling you that his system or your system is tripping at 3 kilowatt, but they've got a 5 kilowatt inverter. It's because your battery can only allow you to discharge up to 0.5 kilowatt. But we've done tests, it's actually 3 kilowatt. Then the Huawei, maybe just to be on the safer side, they classified it as 2.5 kilowatt. But you can get my word, it won't trip before 3 kilowatt. All right. So it's 6 kg, the power module. Maybe while this was still on that, you can actually stack a maximum of 6 batteries under 1 inverter. So that's with the newer firmware version, you can have a maximum of 6 batteries under 1 power module, which means you can build a battery bank up to 30 kilowatt hour. Right? Then obviously it's advised that you can have a maximum of 3 under the inverter. Then if you're exceeding 3, please build it again. You have another floor bracket, then you build the other 3 so that it's not very tall. You compromise the center of gravity and it can end up toppling the inverter. Then you also have wall mount brackets, brackets like these ones. We have them closed. Let me as well show you. Right, we've got brackets like this, so you can also, so for stability, you can actually also mount it, put it on the inverter, then you mount it on the wall so that your system is very stable. Even if it's a floor mount like this, you've got a floor bracket. To gain more stability, we also advise that you just put this, then you stick it on the wall if you think that there's a possibility of someone pushing it over and toppling it. Looking closely now with the basic specifications, it's 6 kg, the power module. Then you can parallel these, by the way, up to 3 on a single phase configuration. So you can't put one per phase and get a combined 3-phase output. I think that's also important to clarify that. You can only put them on one phase. So you are building your power only on one phase. Then the great news is we are on the final stage of testing the 3-phase configuration so that you can have one on each phase and get a 3-phase combined output. And the promise that we have from them is by end of June, that should be ready and, for deployment. 16 kg, it's not heavy. One guy can actually lift the inverter. Then it can be ground mount and wall mount. Then the battery module is 50 kg each. Then the IP rating is 65, IP65. You can mount it indoors and outdoors. Then on the AC input, it's a single phase AC input. Then the voltage range is so wide from 90 to 300. So what it means for an installer now, we are all experiencing grid that is very unstable, especially after load shedding. You can actually have your grid jumping up and down. So if your grid is within from 90, anything from 90 to 300 volts, the inverter is able to give you a stable output. Remember, all the other grid tie or the hybrid inverters, what they do, they don't provide a reference of their own, so they ride on the provided grid. So if your voltage input is high, then your AC output is also high because it's following your reference voltage or your grid, your AC input. But with this technology, it's a UPS-based technology. If the grid is jumping up and down, then the inverter can give you a stable output, 220 or 230. You actually choose on the setup the voltage range that you want. Then 50 and 60 hertz. Of course, in our region, we'll be going for the 50 hertz. Then the surge protection, we've got inbuilt type 1 and type 2 on the AC side and on the DC side. So on your strings and on the AC output, you don't need to put any external surge protection devices, unless if you just want to have redundancy. But you can have that. It's NRI's tested. It's there in the test reports. It's confirmed that there is a surge protection devices which are adequate to give you the protection that you need. Then on the PV input, the startup voltage for the MPPT, you've got one MPPT, 2 strings each, which means all these 2 strings that you are wiring on that MPPT, they should be facing the same roof direction. You can't have the east and the north facing. They need to be facing the one direction because it's one MPPT, though it's 2 string inputs.
I just had a question. The standard sort of average rating of your panel now is 18.36 amps. That's for a 545 JA solar. What is that going to affect it? Because you've only got 18 amps per string. And it's 18.36 on the panel itself.
Then the JA 555 is 14.2.
Okay.
It's 14.2. Is that correct, right? You don't exceed 15, not on any panel that is less than 600 for both the Canadian and the yeah. So this maximum per MPPT is actually 15 amps and 18 amp with the short circuit current. So the nominal is 15. Then you can actually exceed the nominal as long as you are within the short circuit current. You don't damage the MPPT.
Obviously, you can bridge them, but then you're only giving yourself one input.
Yes, you can actually, then you give yourself one input. Then for the Huawei one, it's not recommended that you parallel your strings outside. So you take from your string directly, nothing else in between. You don't parallel them, no combiner box, no protection box. Then you run it to your MPPT. So you are not worried about the panel size. You can use almost any panel size on this unity, right? So the operating voltage for the MPPT is from 100. It's actually from 90 to 435. Then the startup voltage is 100. So you need at least 2 panels for you 3 to be safe, for you to start up the MPPT. Otherwise, if less than 100 volts, then the MPPT won't wake up and start operating. But now if you've got 2 panels, let's say you've got 2 panels, then the moment they start operating, then the voltage drops below 100. Then the MPPT will still continue working unless if it drops beyond 90 volts. So the operating is from 90, but the startup is from 100 to cater for that, at least a 10 volt voltage drop, then you still be fine. Then you can have up to 5,000 watts. Okay, there's a question there.
So the start of the battery is 600 cycles, is that a full cycle?
Yeah, it's
If it's running like a UPS and it's got 0.2 seconds, 0.02 second interval changes,
right.
it's picking up faults on the main grid, and it's acting like a UPS. You can reach those 600 cycles in a couple of weeks.
Yeah, so it's 6,000. So it's 6,000 cycles. Then the Huawei have got a system, unlike all the other system. The Huawei has got a system that actually gives you what is called the half cycles, unlike all the other battery systems, which means if you drain it, let's say from 100 and up to 65, then you charge again. That is considered as a half cycle, which means you can have 6,000 times 2, 1,200 half cycles on this unit. So unlike the other batteries, the moment you drain from 100 to 8 or to 85 or to 70, then it's considered as a cycle. So Huawei now allows you to drain, as long as you don't take more than 40% usable percentage, then it's a half cycle. Then you can take 40, then later on after another, when there's another load shedding, you take 30 or 40, then it becomes 1 cycle. So in terms of the life, it's 6,000 cycles, which is massive, especially considering the other batteries there in the market where we talk of 4,500 cycles, and there's no lithium that can actually give you more than 6,000. Then on the PV's input, you also have that inbuilt type 1 and type 2 surge protection. Then the AC output, the output voltage, you can actually set it. It can be anything between 200 and 230, but we've got an allowance when you're commissioning that you can set it at 220, you can set it at 230, depending on your preferences. Then the maximum output current that you can get in off-grid mode is 25.8. Then if you multiply that by 230, you still get your 5,000 kilowatt, which means the inverter can give you 5,000 kilowatt, whether you're on off-grid or you're on grid. You have got the AC, the grid input. Then it operates at 0.833 power factor, right? Then I also realize that when you've got grid, then the inverter is riding on the grid, then your sine wave is more pure. Then when you lose grid now, the inverter generates its own reference. So there's bound to be some distortion in the purity of your sine wave. Then those harmonic distortions now on the Huawei system, they are less than 3%, as you can see on the rated output. So it's a minimum and very small in magnitude of the distortions that you are getting. So you are guaranteed that even if you are on off-grid, you are getting a pure sine wave. So this was actually important when you are dealing with communications where the purity of the sine wave is important. So this is not only giving you a power output, but they call it clean power. So actually having a clean sine wave on the output was meant for the telecommunication circuitry, which is sensitive to the purity of the sine wave. So even if the clients or the end user might not see it, but you are guaranteed that you've got a system that is giving you a very pure sine wave. What it means now is you have got your compressors, let's say your refrigerator compressor will live longer, because we know in the house maybe that's one thing that is sensitive to the purity of the sine wave. And if we've got an alarm system and other gadgets, they are receiving clean power, then they can actually be able to have a greater and a longer life. Then on the battery specifications, it's a high voltage battery system, right? Then you can't use this Huawei inverter with any other battery. Then you can't use these Huawei batteries with any other inverter. So it needs to be a Huawei battery and also a Huawei inverter. So it's a high voltage battery pack with a voltage range of 350 to 435. Then nominally it's at 400 volts. That's the voltage output that you get from each battery. Then the batteries are in parallel. You can power a maximum of 6. The voltage does not change, but now your current changes. So if you've got 2 of those, if you've got 1, you are limited to 2.5 kilowatt. If you've got 2, now you can have 5 kilowatt. Then if you've got 3, 7 kilowatt, 7.5. No, it can't be 7.5 because now you are limited to the size of the inverter. We had another client who was saying, oh, so I need 3 batteries so that I can have 7.5 kilowatt. Then if you want more than 5 kilowatt, what you are going to do, you're going to buy now another power module. Then you stack your batteries again. Then to get more than that, then you'll be at 10. Then it's advised and it's recommended that each power module should have, across your parallel connection, you should have equal number of batteries. So you can't have another module with 5 batteries, then the other one is got 2. Otherwise, the one inverter is going to discharge and go to 0 before, while the other one is 2 on. Then you lose your inverter power and now at 5 kilowatt. Then if your loads were greater than 5 kilowatt, then you're going to have your system tripping. So this is now talking to the life 6,000 cycles. Then the 6,000 cycles, you'll be at 25 degrees, then going up to 80% DOD, right? 8% DOD. Then this battery module, you can actually use everything that is stored. It's a usable, all that 100%, the 5 kilowatt hour, it's a usable capacity. You can drain it until it's 0, gets to 0%. But we recommend that when you're setting your shutdown SOC, you'd rather set it at 5%, 3% if you really need to use everything. 10% if your system allows. There was a end there.
Battery charges, are they built into the battery, into the power module?
Come again?
The charging for the battery,
Yes.
is it built into the power module or the battery module?
It's built in the power module. So the charge is built in the power module.
So the more battery modules you have, the slower the charge time.
So you can actually, so the charge is determined by your inverter size. So this inverter is a 5 kilowatt inverter, and you can use all that to charge your batteries. What it means, if you've got one battery and you are charging at maximum, you need an hour from 0 to 100%. If you've got 2, you need 2 hours. If you've got 3, you need 3 hours, because the inverter can only charge at 5 kilowatt per hour, which means, since it's also a 5 kilowatt inverter. Right? Then if you've got one, maybe you might not need to charge it at 1C, you can charge it at 0. If you've got one battery, you can charge it at 0.5C. But remember, you can, they actually made it when they are adapting it from the sites to the residential, they changed the BMS on the charge. So you can charge it at 1C, but you can discharge it at 0.5C. So which is also a great thing. So for you, if you've got frequent load shedding periods, let's say you've got 4 or 5 load shedding periods per day, then when you lose, when grid comes back, you can charge it quickly. If grid is available for an hour, your batteries are full again. But when you are discharging, then it drops to 0.5C. So the cells can actually support that, but the BMS is limiting the cells to 0.5C on the discharge.
All right. Because it's such an enclosed unit, the neutral earth bond and off-grid mode, does it have that?
So it has got those dry contacts. I'm going to look at that also in the next slides, few next slides. So you've got a dry contact. It can support your external. You can actually wire that contact to an external relay. You've got your earth and your neutral, the normally open. Then when you lose grid, then you bond that. Then when grid is available, it opens again. So we have that. Right. We spend a lot of time on these slides because these are actually pretty much summing up everything in terms of specifications. We've got few slides that we can just rush through. Some of the things have been covered by Raf, but if we've got anything that we see that has not been covered, then you can actually highlight on that. So the architecture has been covered fully. IP65 can put it outdoors or indoors. Like Raf says, maybe if you've got pit bulls there, you can put it outside, or if your security is enhanced, then you can actually have it outside. It takes only 0.1 square meters, the floor, the space that it needs for this system. So you're not looking at a lot of space that you need to mount this. Then less than 2 hours to do this whole system installation. So to mount the system like this takes maybe 20 minutes to stack it up, because it's M4 connectors. Then remember, it's a high voltage system, which means the current is so low. That's why you are using 6mm cables. The maximum current that you can have is only 12 amps, because we are multiplying 12 by 400 to get more power, but from just a low current, the voltage is high. So that's what's great with this. So it's MC4 connectors. They're already made for you and creamed for you. So it's plug and play. The paralleling cables and the battery communication cables, it's made for you. It's plug and play. Even the earth cables, because you need to connect your earth between your battery 1 to battery 2 and make sure that the whole unit up to the inverter is got the same earthing potential. Right, so all those is meant for you. Those cables are meant for you. It's plug and play. Then you screw them in. So if this takes 20 minutes maybe to do, then the other 1 hour 40 minutes maybe we're looking for a scenario now where you are splitting your DB and making sure I separate the neutrals. As you already know, the neutrals for the backup should never mix with the neutrals for the grid, right? Then you need that earth neutral bond. I understand in some other regions it's now mandatory, so you must have it. then these inverters are equipped with that dry contact relay, that to make sure that if you want to have that externally, then it's easier for you. You can actually wire through a relay, then your relay can change states and bond and open and close that bond depending on the availability of grid. Then you don't need to come and bond on the output, you just bond permanently, because when you've got grid, remember, you already have that neutral and earth bonding, because your neutral is tapping from the center point of the transformer, right? So which means your neutral is earthed. But when you lose grid, that's when you want the system also to bond. You lose that bonding. Then if you put another bond again, you've got another bond at the ESCOM transformer, then if you put yours again when grid is available, you can actually end up tripping your earth leakage. If you guys, maybe if you've made that, if you bond on the output, if you bond your neutral and your earth, you can actually end up tripping your earth leakage, because now the grid bond that is in the grid, ESCOM provided on the transformer, and your bond, they become two different bonds. If they are at the different potential, which means there will be a current flow. That current flow can actually be detected by earth leakage, then it trips. So you need one bond at a time. So when you've got ESCOM, don't worry about the bond. Your relay should be normally open. The moment you lose the grid now, you have lost that transformer bonding. That's only time where you need that relay to close.
So the system does put 110 volt on the neutral and 110 volt on the live circuit, because that's why that bonding is required. So if it loses the grid, when you pick up 110 on the neutral and then combine it.
Yeah, so if it
That's designed.
yeah, it's designed not like that exactly. So maybe as a rule of thumb, if you want to see if it's not about complying with the requirements, right? If it's not a mandatory requirement in your region, you want to see if you're gonna need that external relay or not. You just drop your ESCOM, then you go on your earth and neutral on the output, you measure output. If your earth and neutral is giving you more than 20 volts, then you need that according to the SANS regulations.
It's 110 on the sun.
So 110 now, that would be especially high. But on the sensing, remember the problem now is actually the 110 is coming from internal, not from the earth neutral bond. So you can actually, on the sensing, you can open the sensing, then you go and cut those bridge pieces. We've got communication from sensing, official communication from sensing, allowing you to do that and not compromising your warrant. So you open the front cover, you've got two bridge pieces that is there, then you cut them off if you are having that problem of getting the 110 volts. Because remember, the sensing inverter was meant for the American, European markets and us, those who are using 220 and those who are using 110. So if you see yourself getting 110, it's not coming from grid, it's actually coming from the inverter. Because now, on those outputs, if you've seen on the sensing outputs, now they've changed, now they're actually adapting it. You actually had 3 terminals, and the temptation is to think that it's live, earth and neutral, but it's actually 110 volts and 220. So if you see on the 220 terminal, you're getting 120, open your inverter, cut those are the double output bond, then your inverter gets to 0 and 220.
You have to have the 0 volts on neutral linking to your earth, otherwise your earth leakage units won't work.
Yes, it's going to trip. But remember now, the earth leakage trips not more for the voltage, but for the current. That's why the tests have actually determined that if it's less than, you need to have 0 ideally, but it can't be 0. I mean, 5 volts, 6 volts is good enough. Then if it's less than 20 volts, you can actually have your inverter working that scenario without tripping. Then if it gets more than 20 volts, that's when you now need to bond. When you are bonding into neutral, now you are just shorting into neutral, you are shorting into earth, so that whatever voltage that is there goes to ground. It's now on the ground level and it becomes ideally close to 0. So 0 is the ideal, but you might not get 0. Then it will be 1, 2. Then if it's 1, 2, you are not worried at all. You can continue with your system. But if it's get more than 20 volts, then that's why you should start worrying, and you need that, whether the rules require it or they don't require it.
You have to simulate the neutral bond that exists on the transformer.
Exactly. Right, then your system, simplified use, we have actually covered that, but you can have it anytime. You can also put, you have your Fusion Solar account. You as an installer, you can open a Fusion Solar account. Then your end users, you also have them, give them accounts. So you as an installer, you can have 50, 100 of these under you. Then you give access to each end user to their respective site. So you've got sites under you, then each end user only has got access to their own site. Then if you can check on this now, there's the genset integration. Ralph, my colleague, has also typed about it. So we actually don't have a genset port. So we don't have a generator port on the inverter. So the integration is also a semi-integration. It's not a full integration where you actually have your gen port, you wire your generator to the inverter. But when you are wiring your generator, you need to wire it on the grid port via a changeover switch. That's one thing. Then the integration part of it now is the inverter is wise enough and is intelligent enough to change a relay contacts. So when, let's say you lose grid, your batteries are 100%, you can configure that relay contact that it remains, does not change states. But when your battery reaches a certain threshold, let's say 20% or 15%, what you think is lower, then it can give an output that can start a generator, right? So what it means when your generator starts now, if you've got an automatic changeover, you've got two inputs, the grid, you wire it as your priority input, then your generator, you wire it as the secondary or the backup output. So the moment the generator runs, then the system will detect that I don't have power here, then I've got power on the input number 2, then the changeover switch, if it's automatic, it will automatically change to your generator. Then your generator can be able to supply the loads and charge the batteries. When your batteries are full or they've reached a certain percentage that would have set, then the generator can, the inverter can send a signal to the generator to stop it. So this is the genset integration that we have on the system. So the system has got the smart management where you configure the wake mode. You prioritize the source of power. So the most economic one, you can actually do it the way you want. You can customize it. But the most economic one definitely is when you've got the sun is available, you want to charge and use PV. Then when that is not enough, you want also your battery, to look at your battery. Am I lower or higher than my reserve SOC? Right? If your SOC is greater than your reserve SOC, then that power is actually useless power because you are not using it. For instance, you've got 3 batteries and you know during load shedding in your area, it can only be up to 2 or 4 hours. Then with 10 kilowatt hour, you can actually withstand the worst load shedding in your area. So what it means now is 10 or 15, which is around 66%. Then you can actually go to the inverter, which set 60% as your reserve SOC. So what we are saying is, if I've got enough, if it's a good solar day, I charge my batteries to 100%. That 40% from 60 to 100, I don't need to reserve it for load shedding because I'm not going to use it. I'm only going to use from 60 to 0 to 3%, right? So if PV is not enough, you also want your system to help PV. You want your battery to discharge and help the PV to supply the loads before necessarily going to the grid and increasing your ESCOM bill. So that's what the inverter can do. But now if it drains for some reason, then it gets to 60%. You want it to cut off that and at least take from grid because you know this 60%, that's what I need for load shedding. So I don't want to discharge beyond this unless if it's a load shedding scenario. So that's what you can do with the system. Then if that is not enough or you are now reached your threshold reserve set point, then you can take from the mains. Then if mains is not available, you discharge your battery from the reserve until it's 0. If it shuts down, then your diesel generator now can come in, then it can supply the loads and charge the batteries. You won't be able to see even the lights blinking. Then this is just showing you that for startup currents, then it can withstand up to 1.5. This is also important when you've got inductive loads on site. As you know, an inductive load can take more than its size, maybe up to 5 or 10 times. So there's no guarantee. If it's a 2 kilowatt inductive load, when it's starting up, it can actually draw 4 kilowatt or 6 kilowatt for a few seconds. Then the inverter also helps you to cater for that up to 1.5 its size, which means a 5 kilowatt inverter can actually give you 7.5 kilowatt for a few seconds to allow starting of maybe your air cons, if you've got a pump on site, if you've got multiple fridges, all those inductive loads. Then this picture is just showing you that the difference with the Huawei, sleek in design, streamlined, curvy, it can blend with your environment. If you are putting there, if you look at the pictures, everything is modular and it's compact. The picture on your left is showing you the other system, what they would look like. I'm sure with a good installer, it can be a little bit better in terms of the trunkings and stuff, but definitely be having your inverter and your batteries. But the Huawei is just one unit. You can put it in your living room, you can put it in your bedroom. You can actually install it anywhere, right? The noise is less than 29 decibels, operating noise. You can't even hear it. There are no fans. It uses heatsink for the cooling, so there are no running fans to make any noise. So it could be running and as quiet as this. Then we've got 3-layer protection, that anti-fire pack that Raf talked about. So it's a 3-layer because it's not only protecting you at inverter or the system level, but we've got protection at system level, which is the whole compact thing, then it's also at battery module level and at cell level. So this is the 3-layer protection that we have. We've got sensors that are supervising the operation of the cells. So we've got one sensor per each 2 modules. If you look at the systems out there, you don't get that technology. The best that we have, it will be one sensor supervising 4 modules. But Huawei, they actually made it that one sensor is supervising only 2 modules, taking information about the charge current, the discharging, the temperature, if there's any fault, if the voltage is still within range. So all those systems, you get them. So there's another protection mechanism. If you can see from this, it's a high voltage, 325 to from 325 to 400 volts nominal voltage, but if you measure on the voltage terminals, you still get 0 volts. So that is safe, and it's actually protecting you for an accidental contact, touch, or shorting from to the ground. So if it shorts to the ground, or if you touch the terminals there, you are not at risk at all because it's at 0 volts. It only starts giving that 500 volts when you have connected it and you've plugged those MC4 connectors, and it's now safe and the inverter is in operation. You also have this DC switch. It's an emergency switch. So at any given time, if you press or push in that button, then it stops the whole system. There's also extra protection. Then the fire packs, the self-extinguish module, Raf has touched about this. When you're measuring the temperature, if you get to 90 degrees Celsius, then that automatically sets and is triggered. Then it produces a gas that will extinguish any fire and damage the batteries. Then you still be, after this operation, if you're still under warranty, then you'll be covered by warranty. They won't come now and say, maybe it's your room temperature which had gone high. Because the Huawei, they're actually monitoring the inside temperature of the cells. So if this operates, you're guaranteed that you're going to get a replacement from Huawei, still under warranty. So on the sides, we talked about this. We've got a DC disconnector. So when you've got your strings in, please remember to put that DC switch on, otherwise your inverter won't work. Then you've got the MC4 connectors taking your strings in. You actually have the other extra MC4s in the package, so you don't need to buy any extra MC4 connectors. You actually have more than enough per string. Maybe you're looking to be using 4 or so, but the Huawei, they actually give you 8. So you've got 8 MC4 connectors that you have. Then your battery pack, this for your communication modules to loop your communication wire from battery to battery and up to the inverter. Then you've got your battery input, which is also MC4's 6mm cable, DC cable, normal 6mm, because it's a high voltage and low current. Right, that is on the left side of your inverter. Then on the right side of the inverter, you have got the AC in and the AC output. So these are, it's actually a terminal that you plug in, so you can take it off the inverter, then you wire, you wire it away from the inverter, so you're not terminating on the inverter. Then when you are satisfied that your terminals are tight and the integrity of your terminations is fine, then you can plug it into the inverter. So this also gives you an extra room to work. Rather than coming closer to the inverter when you're terminating, you take it out, then you terminate when you've got all the space and you are free, then you plug it in when you know that the terminations are tight and there's no loose connection. Then you've got the AC output, the same thing, you plug out, and all these now, they've got, how do you call it? On site, we used to call it maybe it's idiot proof. You can't actually interchange the AC in and the AC out. Let's say you took out all the connections, you do the terminations. When you're coming to the inverter, if you make a mistake, then it won't allow you to make that mistake. Then because the AC input can only go to the AC input slot, and the AC output cannot go to the AC input slot. So you are protected there even if you make a mistake, right? On the strings, if you reverse your polarity on the strings, the inverter will give you an alarm. You won't damage your system. But if you make a mistake on the batteries, then you damage your inverter. But it's impossible for you to make a mistake on the batteries if you don't go on site and you clamp your own MC4s. If you are using the provided MC4s and the cables, then you can't make a mistake. They are high voltage systems, and this topology is just showing you that the batteries and the DCs, and the DC or your strings or your panels, they are going to the same bus bar, just like all the other inverters. So you see this is a common bus bar. So your batteries here, they are actually giving an output, 400 volts output going to this bus bar, and your strings from this side is also coming to the same bus bar. So the advantage of these high voltage systems now is when the PV is coming into the same bus bar, it finds that the bus bar is already at 500, which means the bus bar is already afloat. So it's easier for the PV to convert 400 volts to 230, 400 volts DC to 230 AC voltage, rather than coming to the bus bar where it finds a low voltage battery, which is at 51.2 volts. Then for you now, for that mismatch of 51 volts and 400 volts from the PV, which is normally 400 and 360 for 7 or so panels, then it causes some loss, then your efficiency drops. That's why the high voltage system have got a greater efficiency, because it's same common bus bar and the voltages are already close together, they are matching, right? Then if you look closely here, you will realize that these battery modules are actually low voltage modules. It's 51.2 volts here, but now it goes through a bidirectional circuitry which is actually a voltage booster or a transformer. So you are boosting that 51 volts to 400 volts, but the boosting now is happening in the battery pack, in the battery module, before the MPPT or before the common bus bar. So you get more efficiency, more stability on the system because the voltages are matching. Then the different work logics, the modes, for instance, this one is when your PV power, that is your production, is greater than your demand. You don't need an AC, which means your bypass or AC internal relay will be open. You are not taking anything from grid. You're actually using what you are producing from your PV plant. You are using it to supply the loads here and also to charge the batteries if you've got extra power and if your batteries are not full, right? Then the other scenario is when this is not enough. When the power that you are producing from your PV array, if it's not enough to meet the load demands, then you need a second source of power. Then instead of taking from ESCOM and increasing your ESCOM bill, you look at your batteries first. That's the intelligent battery system. Am I higher than the reserve SOC? If I'm higher, then I can safely discharge and help the PV supplying the loads. But if it's lower, then you are taking now from your AC, from your grid. The other scenario is, let's say your PV is not enough, right? Then your batteries, you are discharging 2.5, both the 0.5C. Still, it's not enough. You are producing, your loads are demanding 5 kilowatt. You are producing 2 kilowatt from your strings. Then the battery can give you 2.5. Then you are now at 4.5. Then the other 500, now you can take it from grid. Then the systems are used to be on net equal, because on Huawei divisions, this was for the eyesight power, so it was in telecommunications. That's why from about 2 months ago, it was still on a net equal, but now it has been moved to Fusion Solar, which is the power division of Huawei. So on Fusion Solar now, you can open the account, then you've got end users. They can also get reports from their system. They can get the summary of what they've used from grid. They can get the summary of their yields, what they've used from their batteries, how many hours is the generator run, and what they've used from the generator, and device information and alarms, right? Then your system will look like this. If you've got, let's say, one system, one power module, and we've got 2, 3, or up to 6, then you've got your grid input and your AC output, right? Then your PV strings cannot exceed 5,000 watts effective power. So when you are stringing, make sure you don't exceed 5,500 watts. Actually, you've got a 10% allowance, so you can go only up to 5,500 on your strings. You cannot exceed that, right? If you're in parallel, you can have 3 inverters currently in one phase, in single phase configuration, but very soon, maybe after a month or so, we should be able to put one inverter on its own phase. Then we have a combined 3-phase output, right? So this is a massive battery bank that you can build. Can you imagine we've got this system and we have got 6 of these, so you can actually have 10, you can have 90 kilowatt hour battery bank and a 15 kilowatt inverter power, right? So now in such a scenario now, who needs to put anything on the non-essentials if you've got that bigger battery bank? So if a client needs to back up the whole house, don't worry about the system not being able to feed back to the non-essential. With such battery, we can actually push more on the output if they are willing to increase their battery bank, right? We greatly recommend that when you are paralleling, remember it's common grid, which means you can actually loop your grid inputs, your earth, your live and your neutral, you can actually loop them. But we greatly recommend that you put a breaker here. You put a breaker at this point so that you are able to isolate each inverter individually, right? The same applies to the AC output. It's wise to also put breakers on the output, even though you can actually loop it, but you can put a breaker on each for maintenance purposes. Let's say if one is down, one is fault, then you can be able to isolate that and the other two can continue working. But if you don't have that, you are forced to switch off a breaker that is at this point, at this point in your loop. So it's not great for maintenance purposes. Then on the output, we also recommend that you put a changeover switch. Remember the inverter on the AC output, this is where you put your backup loads. Then if you don't have a changeover switch, if something bad happens to the inverter, then those backup loads, they are taking power through the inverter. So you won't have power to your backed up loads, your essential loads. So with the changeover switch now, a client calls you during the night, you can actually tell them, okay, please put the changeover switch on grid, then I'll arrange the team and will come and attend you in the morning. But if you don't have that changeover switch, then you may be forced to attend to such queries, urgently. So this is all about the eyesight power, ladies and gentlemen. I'm not sure if there's another question that you may want us to look at. If there's another question that you have on the eyesight power.
Just on the generator, it's not like your other inverters that has to have an AVR because of your range and your AC. So does it have to be a stable input from a generator, or can it, like a petrol generator that fluctuates?
Yes, so the challenge that we've been having with the generator, especially the smaller petrol generator, 6 kVA, the frequency is not stable and the voltage is not stable. It jumps up and down. If you look at the NRSA regulations, which is actually a benchmark for the design of the other inverters, the voltage needs to be within, at least if it's dropping 195 to 253. Then if it jumps out of that range, then your system trips. Then the frequency, if you look at the other hybrid inverters, the frequency there needs to be 51.5 Hz, the highest, then 47.5, the low frequency. If it's outside of that, it will trip. But now with the Huawei one, it's a UPS based. Even if your voltage is jumping up and down, but it's within that 90 to 300, then that generator can actually be able to be used with this inverter. Then the frequency range is also wider, from 46.5 to 53 Hz. Then the inverter can take that wider frequency range and it gives you 50 Hz on the dot, because it has got a circuitry that is actually giving you a stable output. It's not riding on what you are giving it. So you realize that if you've got a 6 kVA that you are failing to use on your Samsung or even on the INVT for that matter, you can actually be able to use that generator on the eyesight power, on the power meter. Yeah.
The monitoring system, are there settings there that you can change?
Are
there settings that you can change on the monitoring system? Just purely a monitoring system?
So on the monitoring system, the Huawei Fusion Solar now, from 6 months ago, they've given us access to everything. So on Fusion Solar, whatever you can do when you're on site, now you are able to do it on Fusion Solar, up to even switching off your system.
Can you restrict the users? So is there
Yeah.
Yeah.
So when you are opening, so you as the installer, you've got the full rights definitely. Then when you are giving access to the end user, you actually can assess them. If they insist that they want the rights to change settings, you can give them management role. Then if you don't want them to change settings and you only want them to monitor, then you give them end user or user role. So when you're sharing that plan with your colleagues, they know what they're doing. You can actually give them managers roles. They can also change settings. But we've also realized that with load shedding, if you train or just go and show your client, your end user, it's helpful for them to be able to change, especially your reserve SOC. In periods where you've got load shedding, you want that SOC to be up. You want at least that reserve to have enough reserve to cover you for the load shedding period. But in times when there's no load shedding, Eskom is doing well, you may need to lower that reserve SOC so that you are allowing your system self-sufficiency. When you've charged your batteries, if you lower that reserve SOC, what it means now, when you've got a cloud or a bad solar day, instead of taking from grid, you're actually discharging your batteries. There's no need of keeping your batteries at 70% for 2 weeks when there's no load shedding. So you can actually lower that to 30% so that your batteries are cycling, they're actually discharging. You are charging from the sun. During the night, you're actually using that sunny energy instead of taking from grid. But if you put it up higher, it's safe for the end user, because they know if they've got load shedding anytime, they are covered. But now, during the night when PV is low or zero, then you are forced to take from grid. So if now a client, if you've given that access to your client, your end user, they can actually check on their load shedding schedules. During off load shedding periods, then they lower that. Then when it's during load shedding periods, then they up it. So that way, they're actually winning in both ways and reducing their ESCOM bill.
If you've got a fault on one of the battery modules, will it isolate?
So
can you isolate the module besides physically taking it out of the system?
So if we've got a fault on one of the modules, it actually goes in bypass, which is a good thing, like all the Huawei system. When we've got fault, let's say we've got 2, and battery number 1 has got a fault, you only lose that 5 kilowatt, but the other 5 kilowatt, you are still using it. Then it tells you on Fusion Solar, it gives you an alarm that there's a fault, then you can go and attend while you still have power.
What's the AC pass through on the unit? When on grid?
It's 30 amps.
Still 30 amps.
Yeah, it's 30 amps.
So you don't have a greater on grid?
Yeah, you don't have. You don't have on this. It's still 30 amps.
And no time of use available?
The time of use is available. So you've got also time of use. You've got 5 time periods that you can actually set. For instance, you are saying during the day, don't want to discharge at all. Then from a particular time, you want now to discharge your batteries. You also have that on Fusion Solar. Then you can get your graphs on Fusion Solar. You can get reports. You can automate them. Every month, you get a summary, or every week, if you really need to, even every day, you can have a report. You can automate that every day at, let's say, 7 p.m. When the solar has gone down, then you get a report at every 7 p.m. What have you produced that day? What have you taken from grid? Then the Fusion Solar can give you that for free. Marius? I thought you had a hand up. Marius? Oh, okay, fine. Okay. Last time you had the protection on your arm. Yeah. Now you're fine. Okay. I'm sure there is no another question on the PowerMate. All right. Sure. Thank you. Ronnie, so I think now you can take our break now. Then afterwards, we are coming now for the INVT. All right.
Okay.
Oh, yeah, I'm ready. All right. Okay.
All right, Dex. Enjoy the next round. 1 o'clock we'll go to have our next break, and we'll leave you for lunch to the front end of the hotel. Please join us for a nice warm lunch and a cool drink. And hopefully I'll see as many of you as possible for this afternoon session on the commercial side. And we've got more people joining us for that too, so that's why I'm checking where they're All right, but actually it's fantastic to have so many of you guys join us, and I hope you're enjoying it. Certainly wonderful to be able to host you guys for a change. We'll start doing this more often again. And you're going to be bringing you a lot more new exciting stuff. All right, enjoy.
Sorry, Ronnie, what time is the afternoon session start?
Yeah, you got half an hour for lunch. 1:30. Yeah, 2 o'clock. You'll be already be tired before the
Thank you, Ronnie. Welcome back to our second session of the residential presentations, right? I think this is an exciting session because you are bringing in a new product in the market. And one of the main reasons why this product is coming in, obviously, Ralph has highlighted that it's stock availability. So that was the main reason, right? We didn't have stock for the Sunsync, but that's not all. That was not the only challenge that we're having. Then, looking at that problem where we don't have stock and we want to service our clients better, instead of having them waiting for many weeks for stock, we actually went out to the market. Then we were going to the market, we were not only looking for another inverter that can plug the stock gap, but you actually sit down and we analyze the problems based on the feedback that we're getting from you guys, from our partners, from the installers. Then some of the problems that we're getting from there, we try to solve them using this product. So when you're looking at this, don't look at it as something that is coming to plug in a stock availability gap, but it's also coming in to solve some of the problems that we've already identified, especially from guys who are in the technical team. We are at a point, a central point where we receive all the challenges, the problems, the queries, the complaints from our clients. So when you're looking for a product, also we had strong input in that and making sure that we don't repeat the problems that we're having with these other products. So when we're doing the comparison product, we are not manufacturers, we're just distributors. So there's nothing wrong with the SunSync inverter. But there are challenges with anything. It's got challenges, advantages and disadvantages. So we're actually trying to get a product that will be an improvement from the product that we're having in our product range, right? So some of the problems, maybe if you just want to talk about them, I'm sure you identify with one or two. The problem that we're having when we're having a SunSync, one, stock availability, number one. Number two, we could not use some of the panel sizes that you may want to use on the SunSync inverters. For instance, you could not use a panel size greater than 500 watts. Number two problem. Number three, good product, but if it fails, you needed to wait for 4 to 6 weeks when the RMA process is being concluded for your inverter to be replaced or repaired. So that was also a complaint that we're receiving, a point of distress from the clients. I mean, you come on site, the client pays 150, whatever the pricing, the total quotation. Then you put the system, you realize that maybe out of the box, it had a fault, or else you actually made a mistake. Let's not put it on the product. You made a mistake, you swap your positive and negative on your battery input, then the inverter is up in smoke. You need a replacement, right? Then you need to wait now for 6 weeks. So it's a difficult conversation for our installers to have with the end users. So that's another challenge. Then the other challenge that we're also having was, let's say, for instance, you want to install, but for some reason you can't install a SunSync inverter close to your DB, then you're limited on the 20 meters, the recommended one. So we had a lot of our clients desiring that if that could be 50 meters, 60 meters or so, then that was going to be great. So when we're searching for a new product that we're going to bring at Kathea, we're looking at all those problems and trying to get something that would solve such challenges. Number two, with the SunSync, we used to have the older dongle, the SolarMan dongle, if you remember, which was stable. But SolarMan, that's their business. SolarMan, they're into monitoring platform. It was very stable, but you could not change settings, right? That was a challenge. Later on, we had a new SunSync dongle where you could change settings, but it was not very stable because they are also coming into a new space for them. They are not monitoring platform guys. They are not technology guys. They are SunSync inverter guys. So you realize that with the newer SunSync dongle, you're having challenges like sometimes the site is down, sometimes the data is not correlating, what's the actual production and what is being pushed on the cloud. So all those problems we're going to see in the next few slides, how this inverter solves each of those problems, right? Maybe to give a background, on the RMA process, this is a product that we have more control on. If you've got a fault unit, you are bringing to us. We won't point you elsewhere. Let's say Brian sells a client, then you are calling Brian. Then he says, okay, let me find out from SunSync because your inverter is in the queue at SunSync. But now with this, there's nothing like that. We're not going to point you elsewhere. It all starts and finishes with Brian. It's still Kathea. He should be able to tell you why you did not have your inverter within 3 days. So from that 6 weeks, we've actually reduced the turnaround time to 3 days. And within, if it fails and you bring it to Brian, you've got, I'm not sure Brian won't kill me for that. You can actually go to Brian and say, while I'm waiting for those 3 days, I can't wait. Please give me a loan unit. So some of these that we use for demonstrations, we'll take them to the technical team, then they will become our maintenance units. We can actually be able to cover you and give you this one while you are waiting for that 72-hour period to get a new one or a replacement. So the good news with this, we have a Kathea service center, fully commissioned, and it's actually approved by INVT. So the INVT engineers, they came in, they trained our guys, and they looked at the equipment that they told us, buy this, buy this, buy this. Some specialized equipment is actually provided by them. Then it's there in our service center, will be able to service you fully. So you can see the level of control that we have on this product. I mean, it's difficult when a client is in distress and you are powerless. It's at something, you can't do anything. You can't call, like if it was at Kathea, Brian could call and shout at our Kathea takeout team, but at something now, you don't have that, you can't do that. It's a queue and they've got a lot of clients, but at Kathea, it might be a queue, but it's our Kathea clients directly, so we can service you better with this inverter. All right, I thought maybe let me just give a background. So you realize that it's more or less like a SunSync. Someone was saying, you guys, why are you selling a SunSync? Just looking at it, it looks almost the same. Then I've also realized that in China, when you go to those solar shows, I think there's a guy making these boxes. So it may be different inside, but these boxes, they look the same. It can be a name. I remember I was taking pictures, we got about 5 different names, but it looks exactly like this. So it's the technology that is different, but the boxes, which is the housing, is just the same. So it's also a good thing, a bad thing. It's a good thing because a SunSync client, when he sees this, is a little bit comfortable. He say, oh, okay, this is another different SunSync. Might not even see that it's a different product. The good thing now, it's an INVT product, not rebranded. We only want to bring tier 1 and the right original brands at Kathea. We're not willing to have a branded inverter. Like when we're having the business conversation about this, they're actually offering, do you want us to brand it Kathea? But I say, no, I want to keep your name. So that is also a good thing because we don't want a rebranded something. We want an original product, right? Enough of that. So we've got a 5 kilowatt and an 8 kilowatt pure hybrid inverters, right? Pure hybrid inverters, a 5 and an 8 kilowatt inverters. So the 5 kilowatt looks like this. It's a bit different in terms of the shape and the box. Then the 8 kilowatt is this one, which is the one that we have on top of the table. The 5 kilowatt, the newer shape that will be coming maybe on our next batch will also be looking like this. We've requested the one that looks, they've got 2 versions. We've requested the one that looks like this so that there's no confusion from the end users. You can see that it's still a SunSync. Then if you check, this one has got a smaller screen, which is good enough, but we've got the clients asking for a bigger screen. Then the INVT have got that one with a bigger screen. So in our next batch, we're gonna receive the one with a big touch screen. So those who want to see the graphic and want to see that mimic the graphic on the screen, then definitely they will have that. The 8 kilowatt is a pure hybrid inverter. I can take batteries, low voltage batteries, any battery that is there. It can also work with lead acid and gel batteries. I'm not sure there's no one still using those ones here, but if your client wants to buy those cheaper ones, definitely you can still be able to use those batteries on this inverter. Pure hybrid, you can feed back to grid and get something from grid if Eskom is going to pay you back or give you at least a discount on your bill. You can feed back to your non-essential loads. You can do anything that any other pure hybrid inverter can do. It takes panels, right? It has got a genset integration. It has got a gen port. So it has got a grid port, gen up and gen port, gen input port. Then it has got 2 output ports. So you can see now that the guy is a bit better from the competitors in the market. You've got 2 output ports. So what it means now with 2 output ports, what it means is whereas you're limited now on your output, on your backup loads, when needed to split your loads, you're actually taking some of the loads from the grid port, from the output port, and are putting them on the grid port. Then whatever you put on the grid port, when you lose grid, each and every inverter that is NRI certified, it will go into anti-islanding mode. That is, it will cut off that grid port. The grid port normally is an input-output port for a pure hybrid inverter. It can give you grid and you can supply loads through it, or you can actually give out power through that port when you are supplying your non-essential loads. Then during load shedding, you should cut off that functionality and it only becomes an input port. So for obvious reasons, load shedding is not like losing power. It could be that the Eskom guy has switched off their feeders and they want to work on the lines. So inverter cannot keep on giving an output on that same line. Otherwise, you're going to kill all the Eskom guys. Right? That's why the inverter must be in anti-islanding mode. So the moment it's on anti-islanding mode, no matter how much panels power that you have, right, you won't be able to supply the non-essential loads. So if your non-essential loads were on the output side, you could still supply those non-essential loads which are on the second output port, even if it's during load shedding. So that's the advantage that we're having. To give you a scenario, previously, you have got your essential loads, which are 500 watts, but it's an 8 kilowatt inverter. But your essential loads are 500 watts during the day, right? Your non-essential, your geyser and your oven is taking from the grid. You lose grid. Your panel power, even if it's 8 kilowatt, is only going to produce for the essential loads. But with this inverter now, you can take some of the essential loads, you put them on the load port 2 on the output, so that during load shedding, you're still going to produce and supply those loads. So that's a great advantage, I think, for any installer. Whereas you could just produce 500 watts, you can now produce more for your geysers and for your essential loads. So what it means in short, you have got the luxury of splitting your essential loads further, right? The risk, I heard someone is saying something. The risk now is when you've got that with the ovens and the geysers on the essential load port, you're gonna drain your batteries. Instead of lasting 4 hours, now it's just gonna be 30 minutes or a few hours if you don't have PV. Let's say it's a bad PV day. But this inverter is intelligent enough. When you split your loads, these are essential loads, you put them on load port 1, load port 2. So you're actually further splitting them. This is essential, more important. This is essential, less important, right? You put it on load port 2. When your battery is draining, you can supply both the essential loads first priority and the essential loads second priority. But you get to a certain threshold, let's say 40%, you cut off output 2 and you're only supplying output 1, which is your lights, your essential, not your essential, non-essential, right? So that's a great advantage. So you don't run a risk of running your battery to flat because you can split that and set it on SLC. Okay, I've got 100%, why should I not have my geyser on? It can have power on output 2, but now when I'm at 60% or 50%, I now need to control my usage. Now I'm going to only supply the port 1, which is my lights, my plugs, my secret fans, or maybe my alarm systems and the essential that I want power every time. So this is what the inverter can do. So you can see now that it's solving a problem, maybe that you knew you had, or the problem that you never knew you had. But if someone, an installer, looks at his system during load shedding, it's only producing 300 watts for the non-essential and it's throttling away power. But the PV was a good solar day. It should give you a desire to say, why can't I produce and also use and supply my non-essential loads? But you can't do that because NRIS requires that grid port goes into anti-islanding mode. You should never supply that for safety reasons. But now you can have a second port where you supply it. So this is also the great difference, what actually differentiates this INVT inverter. So when we're looking at these inverters, actually we didn't want an inverter that is new. It might be new in the market, but we wanted an inverter that is dominating some other markets. We don't have an appetite of experimenting and starting something with the newbies. Some of them, the fly-by-night suppliers, but we want something that is already good and dominating a certain market. So all the products that we're bringing in might not be dominating the South African market, but if you check them closely, go to websites or go to look it up, you realize that they are dominating whether European markets, American markets, or Australia, somewhere or in Middle East. It should be doing great in some other regions. So you are not worried to say this is it's new to us, it's new to you, it's new to South Africa, but definitely it's not new in solar. So you can also be rest assured in terms of the background and the homework that has been done and the work and the hours that has been done to try to search for this product. The 5 kilowatt does not have a gen port, so you don't have a full genset integration on the 5 kilowatt. You can start and stop your generator depending on the availability of grid and your battery SOC, but you can't wire it on the gen port. You can wire it on the grid port. That's what the 5 kilowatt cannot do. The newer version will be having the grid port. We have requested for that gen port so that it has a full genset integration. Besides that, just like another hybrid inverter, but now let's look at what's different. So we want to repeat what any other hybrid can do. We try to make sure that we make the slides to highlight the differences. Currently, you can parallel up to 3. You can only have 3 in parallel. So if you're using the 8s, you can have 8, 16, 24 kilowatt in terms of the inverter power. Then they are testing 6. And in a few months' time, a few weeks, 8 weeks, we should be having the ability to go up to 6. But currently, you can go up to 3 on the 8 kilowatt. The good thing, if you've got a 3-phase house or a 3-phase property, you can actually put 1 per phase. Then you get a combined 3-phase output which can drive and power your 3-phase loads. We use Solomon Dongo. So when you say Solomon Dongo, maybe the installer will be using Solomon platforms, thinks, oh, so now I can change settings. But Solomon is a monitoring platform. This is their business. They've got different packages. So for this particular one, we want for Solomon, which is a very stable monitoring platform, then we asked for a package that allows you to change settings. That's why you see the Dongo is a little bit different from the Solomon Dongos that we know. So this is a Solomon Dongo, which is on a very stable, solid platform with over 20 years experience in those platforms. Stable. You never get a Solomon platform down. We never get that. It doesn't go down. The backups and everything is fine. Then you can change settings also remotely using this dongle. So it's not that Solomon, the old Solomon, where you cannot change settings, right? Then that supports Wi-Fi, GPRS, and 4G. The standard one is only wireless. So the one that comes in the package is a wireless one. But if you need GPRS or if you need a 4G dongle, then you need to make a special request. Then obviously you pay an extra. Then they don't take away this one from you because it comes as a standard package. So you'll be having two. Then you can choose the one that you want to use. Then you can keep the other one. For instance, if you don't have Wi-Fi on site and you want to just plug in your Vodacom, Telecom, MTN card, you load data bundles. Then later on, if you have got Wi-Fi, then you can come now and plug out that one. Then you put the wireless one. Then you continue working. Yes.
Just wanted to ask, is the Solomon dongle not 5G capable like the other ones?
So this one is also not 5G capable. You can only use 2.4 Hz. Unfortunately, I'm not sure what happens with all these dongles. You see, even the Samsung, they are not capable of 5G. Maybe our way specialists can also try to shed more light.
All of them are
So all of them, I don't know what's happening.
The thing is that 5G is for close proximity. So unless you're going to install the router next to it.
Yeah.
The 5G is faster, but it's limited to the coverage is much less on 5G, 5 gigahertz.
Yeah.
2.4 is much further. You can find it in the last room,
Yeah.
That is why manufacturers opted to only go for 2.4 gigahertz. And then to put a 5 gigahertz module is more expensive also. And it also is more power hungry.
Yeah. Then the challenge that we also face in that, think of something from that question. When you've got now routers now, it's a 5G router. It actually propagates both 2.4 and 5. Then if you connect that to your dongle, the 5G is smoother. You realize that after your dongle will actually attempt to connect to the 5G network. Then it connects to the network. The moment it connects to the network, it's now offline on the cloud because it's switching and connecting to that network. So it's important to go into your system, your router, then you separate the passwords for the 5G and for the 4G. Make sure they are separate, different names. You give them different names. So it normally comes with the same name. Let's say you've got a RAIN router, for instance. It gives you a 2.4, 4G, and 5G. Then on the 5G, it will be saving same name and same password. So log in via IP address your router, then separate the 2.4 from the 5 Hz. Then you connect only to the 2.4. Then it has got NRI certificate, needless to say. It's already certified by NRIS. Then the maximum discharge that we can have is 210 amps when you're discharging your low voltage batteries. So it's 210 at 51.2 nominal voltage for the 8 kilowatt and 120 for the 5 kilowatt. These are the dimensions, 710 by 430, and the depth is almost 220 millimeter. Then the 5 is a bit smaller at 550 times 520, right? Then on the 5, you can power a maximum of 4. So they've already added 1 on the 5. So the 5s, you can have 4 inverters in parallel. Then the battery bank is not limited, just like with any inverter, right? It's compatible with lead acid and lithium ion batteries, even gel batteries. It's compatible with them. Then all of these 2 inverters, it's seamless changeover, less than 20 milliseconds. Then you've got different mode scenarios. You can use it as a UPS only. That is just you've got your inverter and your batteries. Then you can use it as a grid tie. As you have panels, the client has not yet invested in the lithium batteries. They want to invest later. During that time, when you've got panels in the inverter, they can actually use it as a grid tie. Then you can have it as a full hybrid where you've got all that in place. You've got a PV switch by the side, on the left hand side of the inverter. Then it has got a mechanism to lock it. It's important for that PV switch to remain on when the inverter is under load. Then if you switch it off when the inverter is under load, it causes internal surge because the voltage goes down. When the voltage goes down, what happens to the current to maintain the same power? It attempts to go up. So as this is approaching zero, then the current is going to approach the infinite maximum. So you're going to have a surge. So it's important to switch off your loads at the output first before you switch off that PV breaker, right? But now there can be kids like what someone said, or someone who might not have information. He wants to switch off, he doesn't know the switch off procedure. So now we have got a padlock, a mechanism to put a padlock there where you can lock now and make sure that no one tampers with that, number one. Then if you look on the side here, we've got a button that we have, it's called an EPS RSD switch, where you, after making all connections, then you need to go and push that in to start your inverter so that it can be on and starts working. So someone can also come and press that, let's say depending on your where you mounted the system. Someone can come and press that without knowing, or playfully if it's kids. Then you also, the inverter is intelligent enough, after commissioning you can go to the system, then you deactivate that button so that even if someone comes and presses it on. So you've locked the padlock, you've got a padlock on the PV, then you also deactivate in the system that button so that even if a kid comes and is pressing there, nothing happens, the inverter continues working. So if you've got if you're supplying critical loads where you don't afford any power outage, then this switch and these functionalities, they become a hand and they can give you more. With the user-friendly operation HMI, it's smaller at the moment, but good enough. Then the bigger one is also coming on the next batches of the inverters that we're going to have. Then underneath, you've got an 485 interface for your dongle. It's screw in, then you make sure you lock it, you screw it in until all the threads are finished, it's secure, and the lights are on. Then if you connect now, you are guaranteed that you'll be having a stable connection. Then you've got the battery end, you've got glands there for the battery. Then it's important after glanding, make sure it's tight so that you don't compromise the lighting of the inverter. It's IP65, you can mount it indoors and outdoors. Then you've got your PV connections. We're going to look at the connections, and in a few moments they are a bit different from the ones that we are used to. Then you have got your load interface which is your load port 1, load port 2. Then we've got your grid input and your gen input, as can be seen underneath. But after this session, we're going to break it one. So after the slides, we also want to have an opportunity where you can go to the Huawei, we dismantle it, to mount it together, those who are willing. While we're waiting for one, then we also go to the NVT, we open it up. So there's no need of really talking about this because it's something that we're going to be able to see. But just giving a background so that when we're seeing or confirming what we've already talked about. So the generator, we've got relays on the inverter which can start and stop the generator based on grid availability and the SOC. Just like any other hybrid inverter in that matter, it's not uniquely INVT. Then in the package, you have got your hybrid inverter. Then you have got your user manual, a hard copy. So the hard copy is available, then the soft copy is available. So if you're old school, you want to read it from the pages, then you have your hard copy. Then if you also want the soft copy, you can contact your account manager or the technical team, then we'll quickly send it to your email. So for instance, you have made an order, you haven't received the hard copy, you can send you the soft copy so that you familiarize yourself with those, with the capabilities and the specifications of the inverter while you are waiting for the hard copy. Then the expansion screws, everything to mount is provided for. Then you've got current transformers, your CTs. So the CTs are there. The interface for the CTs is RJ45. So you're going to plug it on an RJ45 port, which is a bit different from the normal one that we have, where you've got two wires that we need to connect for the CTs. This one is an RJ45 plug. You just plug it in. So you are not worried about where am I connecting, which terminals am I connecting on, because it's a RJ45 plug which is written CT. Then you plug it in. I hope no one's going to ask why we've got two. So we actually have two because in future, they want this inverter to be able to integrate two grids. Let's say we've got two feeders. Let's say it's very critical. Then you've got feeder A and feeder B. They are in redundance. Then the inverter should be able to use either of those and be able to do the export control on each. That's why I've got two CTs and two CT slots. Currently, it's not activated. You can only use one grid input, which is the 100% scenario for all the houses that we have normally. But let's say it's a surgery where you don't afford any power outage. We've got actually two transformers feeding to that. in the near future, in a few weeks' time, 8 weeks again, you should be able to hook CTs on each feeder. Then whether you're running on feeder A or feeder B, the inverter can do export control. And you can actually separately configure your export control limitation to say, okay, when I'm on feeder 1, I'm allowed feedback, but on feeder 2, I'm not allowed to feedback to grid. But that is a future capability. So it also shows that INVT are anticipating the market needs, and they are actually actively involved in trying to anticipate that, and the R&D team is working actively to give us solutions that will improve our experience. Then the paralleling cable is already provided for. It's IP65, but it's recommended that you don't put it under direct, you don't expose it to direct rain. You also don't expose it to direct sunlight. So if you expose it to direct sunlight, what happens now is your cabinet temperature is going to build. Then the inverter can operate up to 60 degrees, right? But if you get to 45, then your inverter starts derating. So from 45, for every degree after 45 degrees Celsius, so every degree increase, then you are losing a certain percentage of your inverter capability. So if it was 8 kilowatt, when now you're at 50 degrees, then you can't use 8 kilowatt, maybe to reduce that output to 5 kilowatts. Remember, the less the wake, the less the heat dissipated. So it says, okay, now I'm too hot, so I can still wake, but let me reduce my output power so that I don't keep on producing a lot of heat on the output. If you are installing them, you need to put from the wall, from the roof, you need to leave at least half a meter. Then from the walls by the sides, at least 30 centimeters. But now if I've got more in parallel, increase that 30 centimeters from inverter to inverter to at least half a meter again. So you've got half a meter between inverters if they're in parallel. Then for the 5 kilowatt, it's 30 centimeters, 300 millimeter up on all the sides. Sense? Or we can put it close to the wall as long as you leave 300 millimeters from there. Then the 5 kilowatt, the 8 kilowatt, as you can see, I'm not sure if it's visible from this side. The fans are on the other side. So all of them, they use heat sinks for cooling. Then the 5 kilowatt is smaller, it does less work. Then the heat sinks are actually enough. You don't have any running fans on the 5 kilowatt. Then on the 8 kilowatt, you've got heat sinks and you've got extra fans. So if the heat sink is overwhelmed, let's say you've mounted it in a room where there's no, remember heat sink now needs at least free air circulation. So if we're in a room where it's close by, we just put in a basement where there's no free air circulation, then the fans will kick on now. When the inverter is overwhelmed, then they will help the heat sinks and cool your inverters further. So underneath, it looks like this. You can tell that it's a bit different. It's a bit different from the other inverters that we have in the market. So on your batteries, you've got your battery terminal A and B. It's important not to reverse the polarity. If you reverse the polarity here, there is no second chance, just like all the other inverters. So it's not a disadvantage on the NVT. You damage the battery card. Then you've got your PV input, which is here. Then you can see these ones are pressed. You press it in, then you insert your cable, then you release, then it connects a tight connection. So it saves time. So if someone is trying to put the screws in and pulling, trying to see if it's tight enough, then this guy here, you can actually be able to finish all the strings while you are still on one string, because you just press in, you release, then it's tight. If you reverse and make a mistake, you reverse polarity on the strings, you get an alarm. You don't damage the inverter. Of course, no one wants to do it deliberately, but if you make a mistake, then at least you've got a second chance on the strings. So what it means, in short, is try to pay more attention when you're on the batteries. So now the guys, you see, even here, the guys, they use the same color of cable. Normally, others, they use red and black, but you can have someone just buying one red, then he puts these shrouds, and at the end, he puts the color codes now. So if you make a mistake when you are coding those colors, you may think that you've got a negative while it's a positive, because you just put a red color. So if you want to, if you can, try to separate and have different colors, but if you can't, then ring it out with your meter. Make sure you ring it out before you wire it or before you switch on your inverter. Then you've got a gen port still with the same connection. It's just press and release, then it's tight enough. Then on the 5 kilowatt, it's a bit different on the bottom. You can see that this is a battery termination. You actually unscrew it and you plug it out. You wire it from the outside. You wire it from the outside, then you plug it in again. Okay. Say 15 amp, the current rating of the MPPT, 30 amp per MPPT, then 15 per each string input. Then if you want to exceed the amperage, you can actually go up to 20 on one string input, but now you won't be able to use the next string input. So it's 2 MPPTs, which means you can have 2 different roof facets. You can actually have your north and east facing. Then make sure that the north, you wire them on their separate MPPT. Otherwise, if you mix, then the least producing string will pull down the one that might be producing more. This just showing that this gen port where you go to generator, it's available on the 8, not available currently on the 5. Then the inverter, this we're gonna just look at this. Maybe what you may need to check is the BMS. So the inverter uses 4 and 5 for the BMS. It uses CAN bus, so it's 4 and 5 on the inverter side. What it means now is when you have got a separate or a different battery, you need to match BMSs. BMS is 2 protocol, though it's an RJ45 plugs which may be having 8 strands, but we are only using 2. So you need to know from your battery which ones are you using, and you match that to 4 and 5. Then if you are buying your batteries from Kathea, if you are using a Greenridge battery, it's a standard Ethernet cable. If you are using the Lithium Valley, which is this one that we have here, we're going to look at that maybe in the next few minutes. It's also a standard straight Ethernet cable. BSL batteries, standard Ethernet cable. Maybe when you go to Freedom 1 batteries, which uses 7 and 8, that's when you now need to match 7 and 8 going to 4 and 5. You need to make your own cable, right? It also supports, the BMS supports RS-85. Then if you've got RS-85, you can use pin 1 and 2 or pin 7 and 8. So these are RS-85 pins. 7 and 8 is demarcated, 1 and 2 they put X's, but it's both. You've got redundancy in terms of RS-485 because you may actually need to loop or to parallel the BMSs. But for now, you don't need to parallel the BMSs even if you've got 3 inverters in parallel. You just wire everything on your master inverter. Then the master inverter will convey that information to the slaves. You've got a monitoring platform, which is your SolarMan Business, very stable. So you can download your SolarMan Business installer. Then your client, you download the SolarMan Smart, right? Then if the client is on SolarMan Smart, you won't be able to change settings. So if you want them to change settings and they insist that they want to change settings, you just open a SolarMan Business account for them. Then you share that plant with them. So the screen, the display, the HMI is a soft touch screen. Then we've got 3 LEDs that can actually be on, which is the grid, the EPS, the alarm, and the fault. The grid is just showing you that grid is available. When it's not available, then it's off. Then the EPS is your backup. It's showing you that your inverter is in backup or it's ready to be in backup in case you lose grid. Then the alarm is giving you a warning that does not stop the inverter from working. Then the fault, these are also warning or faults that stop the inverter from working. So if you've got a fault on, you need to attend to it before the inverter can work. But an alarm is just telling you that you need to check this, but still the inverter will be working. Then you've got your display here. Then you've got your interface return, which is your exit. Then your up and down change settings. Then you've got your enter to confirm and save the settings. So after every setting, please remember to press enter so that you are saving and you're actually confirming that this is what you want the inverter to be worked based on. Then the general installation guidelines, make sure obviously it's secure, it's the integrity of the, you are happy with the integrity of the installation. Make sure that it's upright. You don't want to have it skewed or not upright. Then ensure that the instrument is well connected, those terminations are tight enough. But make sure that the polarity is right and the terminations are tight. Loose connections can cause sparks and sparks can cause fire and failure. Then after you're satisfied, now you can turn on your PV switch and your battery switch and the inverter can start working. So when you don't see any of those LEDs on, you should not worry. Your inverter could be in initialization mode or it could be on standby. Then none of those lights will be on. So to save power even on those LEDs, if the inverter is not producing anything, it's just idle. They need to switch off those power. But the moment you start drawing anything from it, then the EPS light will be on and to show that it's producing. Then the grid on, light will be on when you've got grid, and the rest will be off. Then you are on off grid, it's only the EPS light that is on, the rest will be off. Then if the inverter is in bypass, we have got the grid line on, then we've got the alarm on. So it's showing you that it's on bypass. Though when it's on bypass, then there's no guarantee that when you lose grid, it's going to switch over and go on backup mode. That's why I've got that alarm on, showing you that I'm giving you power, but I'm on bypass. You might face challenges when you lose grid for me to switch over to backup. But the normal scenario is when your EPS, your grid is on, or your EPS is on, like in this off-grid mode, right? Or your EPS and your grid, they are on, you know you are sorted. Then the fault, you can have a fault alarm on the fault LED, then you need to attend to this before your inverter can work. So on the quick setup guide, these are just some of the scenarios that we have. You don't need to change a lot of stuff. So this is the only inverter now that is by default, it's already on lithium. So the moment you put that communication cable and you've got a lithium battery, it picks that battery automatically. What you need to change, obviously, is to customize your charge currents and your discharge currents. So the discharge, by default, the charge is 25 amp by default, so you may need to put it a little bit high. Then the discharge is on the size of the 5 kilowatt, so you can actually use it on 5 kilowatt without changing all that. The password, the default password is 5 zeros. We greatly recommend that you don't change the password. We've had a few clients now changing the password, then they forget what they put. And now you need to go back on site and reset the whole system. So please, you can keep it at 5 zeros, I mean. No one who is not aware may guess that it's 5 zeros, so we're still sorted. Yeah, I mean, when you're putting a password, you say, okay, 0, 1, 2, 3. Then you think, it's so easy. But next thing, when you're coming back, then you're scratching your head, you've forgotten the password. So there's at least security is password protected, but you need to, for you to access this setting, you need to know that it's 5 zeros. Then if you're looking it for the end user or any other person, definitely I don't think they can crack 5 zeros. Right, so what you need to check on the PV, you don't need to set anything, but the inverter can actually has got a functionality. Let's say you parallel your strings from the output, from the outside, then you wire them on one string input, you blank the other string input, you can actually come and tell it and configure that you have got a high amp string that is coming. Then you can set that. Then on the battery parameters, you also need to match the battery that you have. If you've got lithium valley like this, but this is our choice battery that will go with, that we're gonna pair with the INVT. We greatly recommend that you pair it like this. We're gonna look at the batteries that we have. I've got two different sizes on the lithium valley. We're gonna look at that in our last slide. Then the wake modes, we've got three wake modes that you can have. The peak shifting, we don't use that normally in our regions. This is when, let's say your tariff is different. We've got peak tariffs where electricity is expensive, the unit is expensive, and we've got the valley where now it becomes low. You can set your inverter to charge during the times when electricity is cheaper, then it discharges when it's expensive. So you can save money from that. Then unfortunately our tariff is almost flat here in South Africa. Whether you're charging at 12 a.m. or at 8, at midnight, 1 a.m. or at 6 a.m. peak power, you're paying almost the same thing. So we might not use that peak shifting, but it's actually what the inverter is capable of doing, which means in future, if with this load shedding, if they decide to discourage using power during peak hours, and ESCOM actually introduces that, then the inverter is ready for such eventualities. We should be able to benefit. Then the self-use, this is the maximum self-sufficiency, where you actually use your system. That's when you get through that wake mode. Say PV first, right? If PV is not available, my battery can discharge. If that is not enough, I can take from grid. If grid is not enough, I can now, if it's not available, then I can now start my generators. So this is the self-consumption, the self-use. Then the battery priority. You can choose now, it's during the morning, you've got the little PV that we get. Do you want it to go to the loads or you want it to charge your batteries fully? I'm sure with the installers, it's a different school of thought there. Others, they prefer to charge their batteries first. Others, they prefer to supply the loads. So for me, I think it depends with the PV that you have. If you've got enough PV, you know that during the course of the day, you've got enough power to charge your batteries to 100%. So the little that you get from 7 a.m., you'd rather push it to the loads. Otherwise, if you push it to the battery, around 10 a.m. your battery is full and your loads are actually lower, you are throttling away all that power. So the little that you have, push it to the loads if you've got enough PV. But if you've got 2-3 panels, then definitely you know that you might not have enough to charge your batteries to full. So the little that you have, charge your batteries and be safe for load shedding before you can supply the loads. Other difference that we have with all these other inverters that we have, when you are paralleling, you've got no way where you specify the number of inverters that you are paralleling. But with the INVT, you actually specify the number of inverters. The difference that we get from there is, for instance, we've got 3. Samsung is also our product. We are selling it. So I'm just giving an example, not to talk down on Samsung. If you've got 3 Samsung inverters, right, in parallel, and you lose communication between your first slave and your second, which is the last slave, the inverter does not know that you have lost that connection because you never told you that you are in parallel and you are 3. So if you lose between the master and the first slave, the inverter will tell you, give you that power stop alarm. But if you lose the last inverter, the inverter has got no way of knowing that you have lost because it doesn't know how many inverters are there. But with this INVT now, you go and specify that you guys, you are 3. So you as the master, I expect you to be seeing 2 inverters. If it doesn't see the last one, to give you an alarm and say, I've lost the second slave. So it's also an improvement from what we were having previously, which means with the Samsung, you can actually think that you've got 15 kilowatt hour or 24 kilowatt hour, while at least you only have 16 or 10. You only know when you're on backup and now you can't supply those loads, you are tripping. Or in other cases, guys ended up actually all the power now, all that set point from the CTs is going to the master. The master should actually split the set points and send it to the slaves. So if you lose one of the inverters, all that burden comes to the master. And we've had few situations where the master now is damaged by overload. Remember, we've got an overload protection, but it can only protect you thus far. If you require 50 kilowatt from an 8 kilowatt hybrid inverter, then you damage that inverter. But if you are requiring maybe, let's say, 15 kilowatt from 8 kilowatt, it will protect you in that trip. But now if it's the magnitude of the overload, determine level of protection. It can't protect you from any overload situation. It protects you to a certain extent. These are some of the fault codes that you can have on the inverter, but they are there in the manual. No need to look at them now. On the overcurrent on the strings, you can use any panel size on this up to the 555s, because it's 15 amp, 18 amp short circuit. Then even with your 555s, then you don't exceed the short circuit current that we have on the INVT. So in short, that was the INVT. So I'm sure we've managed to cover the background and also shown and demonstrated why it is not just a product to cover the gap, but it's also an improved product in a number of areas. Those 5 areas, if you may think of them, you can use any panel size, no problem. The RMA process is shorter. We can give you a loan unit. We've got an in-house repair center, and we repair at PCB levels. That's also important. We don't go and disorder the components. So we've got equipment. Inverter is made up of different PC boards, the power PC board, the communication, the inversion circuitry. So we take the PC boards, we put it on that machine. It tells you, it checks the tracks, then it tells you this PC board is fine. We put it back. The one that is fault, we put it in the bin. We put a new one. We put those 4 screws and we plug it on that bus plug. Then we box it up, we give it to you. So you are guaranteed that the inverter that you are receiving, no one was soldering resistors and capacitors. So it's still good enough in terms of the quality. All right, it's at PCB level only, not at component level. If you are covered under warranty, then we'll do it for free. Of course, we've paid for that warranty in case. Then if you are not covered under warranty, the account manager can still use discretion. Well, let's say you make a mistake. Remember, warranty cover covers up to this much. But if you make a mistake, you actually say, come to the account manager and say, hey, no, guys, my guy was new, then or maybe I actually, anyone can make a mistake. I swapped polarity, and this is what I did. Since we've got more control, the account manager can actually, by discretion, say, okay, you are my important client, then you're going to repay it for free. Or we're going to charge you, instead of charging you 1 rand, we're going to only charge you 50 cents. I mean, we've got that control in-house, which is also a great thing, and to cultivate good relationships and make sure that we service you better. Then the CTs, we can extend them up to 70 meters. So whereas you could go up to 20, this you can go up to 70. 70 meters away from the DB, which is good enough. No one wants to be that far, further than that. So these are some of the advantages that we have. Then when you are paralleling, I know everyone now when you're paralleling, please update the firmware version. But with the INVT, this factory firmware version is good enough for paralleling. I mean, we've had guys saying, you guys, you are telling me to upgrade this firmware version. So as you are telling me that you put a firmware version from the factory that is not good enough. So the INVT, they are confident in this. You don't need to call or contact anyone. I mean, we've been telling you, if you want, before you parallel, please give us, you have internet on site and give us the serial number so that we upgrade the firmware version for you. But with this, you don't need internet. So which means if you go to a site where you don't have internet, you can actually parallel this and commission without internet. So it's also a great thing. We've had guys stuck, they can't commission for 2 days because the end user hasn't bought the router, right? Or maybe the router is upstairs, it's far away. You cannot, you don't have extenders to have, you have got a bad signal strength in the garage. So that now, with the INVT, you won't face such challenges. It's just putting parallel cables, then you commission the system with that very firmware version, right? Then the load outputs are 2, maybe that's the 5th advantage. Also, you can be able to have more on your output. But please, we've said you can take some of the essential loads and put them on the backup. But make sure that the combined power of your load port 1 and load port 2 does not exceed the inverter size. Because these are pass-through currents. We've had a guy now putting everything. Oh, now I don't need any non-essential. He loads the inverter too. It's fine. But now when you are drawing, because remember, the essential ports, they draw through the inverter. So you can't exceed the inverter size. So make sure that if it's an 8 kilowatt inverter, you output 2 and 1. The summation does not exceed the inverter size. Yeah, so these are the advantages. Plus the 6th one, SolarMan is a stable platform. The platform, then you also have the privilege of changing settings. So this is what makes it different from the SunSync and other competitors. Maybe also just to give 1 or 2 disadvantages to be fair. Currently, you can power a maximum of 3 on the 8 kilowatt, whereas on the SunSync you could go up to 9. So in systems where you don't need more than 3, then perfect. But now if you needed more, that's a limitation on this. Currently on the 5 kilowatt, we don't have a gen port, but it's gonna come. But that's what it is now. I mean, someone said if you only give advantages without disadvantages, then it ceases to be an advantage. So these are maybe the limitations that I can think of.
Can set up as a 3-phase system?
Yeah, you can set it up 1 per phase. So
So
it's a maximum of 3 in parallel. So if it's in 3-phase situation, you are limited to 1 per phase now to get 3. Yeah. So the maximum that you can have is 3 in parallel. That's why they're going to 6 so that you'll be able to have 2 per phase. They also believe that in the residential space, if you can have 2 per phase, 2 times 8, 16, then 16 times 3. Then they believe that in a 3-phase scenarios, then you should be covered. But we've been telling them and giving them feedback that some of our clients, a few as they may be, they actually require more to have more of these in parallel. But at Kathea also, you're gonna look in, when we check the commercial setting, you see that we now have bigger inverters. So if you want that big system, we can give you a 30 kilowatt, we can give you a 20 kilowatt, we can give you a 50 kilowatt. So we're gonna go in depth, introducing also those new products that we have in that space. So we're actually putting it on commercial space, but bigger residential areas where you need a 20 kilowatt inverter, you can actually have that 20 kilowatt instead of paralleling 3. Then you only have 1 inverter and 1 battery bank. Then it gives you that flexibility. Then with all this, you can have common battery bank. Then each inverter is tapping from a common battery bank through a fuse disconnector. It's important to have a fuse between the battery bus bar to each inverter to protect the inverter. While you are still on that, we've said this is our battery of choice that you can pair with the INVT. Okay, maybe while you are on the inverters, any question on the inverters before we look at the batteries, so that we just cover them as they come.
just on the output port, because you've got 2 ports now, if your staff accidentally, because obviously if you do a parallel system, you're going to breach the outputs.
Yes.
If you breach output 1 with output 2, for instance, will it give you an alarm?
It will give you an alarm. It will give you an alarm and you won't be able to operate with that. So these are separate outputs. You can be able to switch on or off individually. So now it's not at the same point. You can't parallel across then you get an alarm for that. You get an alarm for that if you make that mistake. I think it's an important point. When you're paralleling now, you're combining those outputs. So make sure that the live on port 1 is being looped with the live on port 1 and the live on port 1 on the last slave. You can't say the lives, all of them are putting them together. You short those inputs internally and your inverter will give you an alarm.
The neutral earth bonding relay is the same thing.
Yeah, the same thing, standard. So actually you have 2 dry contacts, normal open, normally closed. So you can use those ports. We actually call them maybe earth neutral bond, but you can use them the way you want. It's a dry contact, yeah. You can use it to start a generator. So we've got 2 boards. One may want to use one to start a generator and one to wire it on that external relay. Then you can use it to an alarm. Let's say you set it at 30%, you want to ring a buzzer and say my batteries are, you can configure it any way that you want, yeah. It's just a potential free contact. Any question on the INVT? Then we can't pair with the 5 and the 8. You need same size. The firmware version is fine, but same size when you're paralleling. Yeah, I think we have covered everything. Seems like we're together. I mean, there are no questions, which is great.
Can I just confirm something?
Yes.
You can use up to the 550 watt panels on both the 8 and the 5.
On both the 8 and the 5 to confirm. So remember, it's coming in to solve that problem where we would say, oh, in the 5, don't use this panel size. And you realize that the 460s are out of stock. You only have the 555. Then you also have clients having that challenge. Say, no, but I can't get a 460 anyway. So how am I going to use my 5 kilowatt inverter? But with this, both on the 5, thank you, Brian, and on the 8, you can use any panel size less than 600. Less than 18 amps actually, less than 18 amps. So let's not size it using the panel size. But the good news, the J and the Canadian, at maximum current that you can get there does not exceed 14.5. So at 15, which is the nominal, you are still covered. Then at 18, which is the short circuit, you actually have freedom to exceed the nominal current. Then the lithium batteries, we've got 2 that we have at Kathea. The 5.12 kilowatt and the 10.24 kilowatt. They can be wall mount or floor mount. Then if you look at the picture, I'm not sure if it's visible enough. If you look at this, we've got these small legs that we have, which means you can actually put it on the floor. It has got a clearance in case there's water spillage or any liquid. So it's a little bit raised off the ground. It's a beautiful battery. I'm sure you can agree with me. Just by looking at it, even from the back, you can actually tell more or less what percentage do you have with those LEDs confirming the battery percentage, right? You can parallel these up to 15. So you can have 15 of these in parallel, whether it's 5 kilowatt or 10 kilowatt hour, right? There are 1C batteries. You can actually, from a 5 kilowatt hour, you can drain 5 kilowatt continuously until it's flat. 6,000 cycles at 8% DOD, the end of life 8% again, then 25 degrees when you are running at 0.5 C. So what this line is actually saying, they are confirming that when they did the tests, simulating those tests, they were not at 1 C, they were at 0.5 C, and the temperature was controlled at 25 degrees. They were not draining it until it's 0, they were draining it until it's 20%. So 28% DOD, you are using only 8% from 100. At 20%, you are shutting it off, right? It's 100 amp hour for the 5 kilowatt hour, then 100 amp hour for the 200, for the 10 kilowatt hour. Then the dimensions, these are the dimensions. The 5 kilowatt is what you can see. 96.5 kgs for the 10 kilowatt hour, this one, and 47.2 for the 5 kilowatt hour. The operating temperature is higher, whereas some of the batteries, they can't operate when the temperature goes beyond 50. This one can operate even at 55 degrees. It's IP rated 65. You can put it outside, you can put it indoors. It uses RS-25 and CAN. You can use any protocol of your choice. It has got a fuse disconnect by the side. I think it can be seen here. So what it means now is you don't need to go and buy that fuse holder and the holders, you have it. So the other batteries that attempt to have such in the market, they only break one line, the positive. And with the SANS regulations now, they require to break both. But now with this lithium value, you are breaking both the negative and the positive. So you've got enough protection on that. It's a 125 amp, right? So 125 amp, which means it can protect an 8 kilowatt inverter, a 5 kilowatt inverter, while it's giving you the maximum output. But if you are going now, if you are going to if you've got many in parallel, then now you need to put them on a common bus bar. Otherwise, you'll be limited by this fuse. So if you've got many in parallel, put them on a common bus bar. In any case, the cables that are provided for, it uses an FNO connector. You are not screwing it in, so you are plugging in with an FNO connector. It's a 25 square. With the current, it can actually go up to 130, 135 amps. So when you've got more in parallel, you now need 10 kilowatt. You can have 10 kilowatt, which is 200 amp in that cable. So you are going to a bus bar. When you say a bus bar now, someone is saying, oh, now I need to buy an extra thing. I mean, in bus bar, we're talking of 200 or so rand. I mean, 200, 300 rand. You just buy a copper bar for the negative and another copper bar for the positives. So if you say call it a bus bar, it may sound fancy, but it's just a copper bar, which is a very cheap. Then from that copper bar, you are buying an extra thicker cable, 35 square or 50 square for an 8 kilowatt. But the 8 kilowatt, 200, it's up to 240 amps. So a 35 square is good enough. If you check on your current carrying capacity table.
So far, are they providing the ethanol plugs now with the battery?
So that's also an improvement from the other batteries that we have. So with this lithium value, number one, it's an original battery, right? Original manufacturer. So if you had a situation where someone with the old, we know something, they don't manufacture batteries, they brand batteries. So if you had an old something battery, it's another company. The newer, it's another brand. So that's why you can't mix both. But this is an original, which means in future, if you buy two of these and you want to buy another versions in future when this one has been discontinued, still the same company, you can pair all those ones together. That's why we also have the advantage of having an original brand. But if it's a rebranded, you go to them next time. They've changed partners. They're using another battery. It's written the same name, but it's another battery altogether and another BMS. You face those challenges. So coming back to your question, with other batteries, you only had one set of FNO connectors. But with this one, you get this, then you also get two extra, the positive and negative. In case you want to parallel, you can now crimp the other end. So the other end is not crimped, the other end is crimped with the FNO connectors, but you are provided two positive and negative in the package. So you are sorted, you don't need to go and buy it elsewhere. Another advantage, whereas maybe on the Samsung batteries, you are still limited to 8, but this can go up to 15. You don't have any deep switches. It does the auto addressing. Remember, when you've got batteries in parallel, each battery should have its own unique name, which is the Modbus ID, that the BMS can call and say, okay, battery number 5, what is your charge current? Battery number 5, what is your temperature? Battery number 6, it calls them individually. It can't just be one Modbus ID. So you need to change deep switches when you've got when you're buying a Greenrich battery. The ones that we're selling, not talking bad on them, but just doing a comparison. If you buy a Greenrich, you need to set the deep switches accordingly. But if you buy this, you don't need to set any deep switches because it does it automatically. What it means is you just come and switch on your master pack. Then the master pack, when it's on, it will start searching for the slaves. Then when it finds the slave, it switches it on. So when it finds and switches it on, it's peace of mind for you as an installer because you know this now has been on. I did not switch it on, which means there's already communication between the batteries. But whereas if you set the deep switches, you don't have a way of knowing if the batteries are communicating. If you make a mistake on the deep switches, during load shedding, your system is tripping, you only realize, oh, I was discharging 2 batteries, the third one was not working. But when you move away from site on these batteries, you know for sure that it's working because all the slaves, you did not switch them on. They were switched by the master, showing that there was communication established between the batteries. Right? So it saves you, it gives you assurance that all of the batteries are in parallel. Then it also eliminates the possibility of making a mistake on the deep switches. Then it's quicker. You don't need to consult the manual and do those high-low, those digital addressing. It does it automatically. You don't need any external fuse It's already provided for you. You don't need to go and source the FNO connectors. When you want to pair with the batteries, everything is provided for you. So these are the advantages that the Lithium Valley has. It's 1C. Then you've got different ports here. We've got the link A and link B, in and out. That is your 3 and 4 here. Then these ones, whereas the other batteries now you need to put in, out, in, out. These ones you can put them anyhow. It's the same daisy chain. So it doesn't matter when you're going to invert out your battery, you can put it on any port. You don't need to be extra careful, right? Then the CAN and the RS-45 is provided for your BMS. Then you've got also an RS-232 port that you can use for, this for programming when you want to program or you want to calibrate, do the manual calibration of your system. So this is the Lithium Valley system and the INVT. Do you have any question on those two?
Communication between inverter and battery only master as well? So
Only the master, exactly. So you are daisy chaining them, link in, link out. Then from your master battery pack, you are going to your master invert. Yeah, going to your master invert.
Your communications cable is standard RJ45.
Yes, they are standard RJ45 and they are actually provided for. Then the communication between battery and battery is RS-45. Then from your master battery pack to inverter, it's CAN bus. So this is standard, but it uses RS-45 protocol. Then the CAN is only from your battery number 1 to the inverter. Then it's provided for in each package. So you have got extra. The inverter comes with 1. Then the battery comes with 2. Which means you can parallel, you can use one for paralleling, then you can also use one for paralleling the inverters, then you need an extra one that to take from the Lithium Valley going to that inverter.
The battery is compatible with other inverters as well, right?
Oh, thank you, that's important. We recommend this pairing, but you can buy the inverter and use any other battery. Then you can also buy the battery and use it on any other inverter. It's a lithium battery. It's compatible with all the other inverters as long as you match that 4 and 5 on the CAN bus. So you are not limited. Let's say you've got your system already, you want to buy this battery, please feel free to buy the or buy the inverter only.
On the data sheet of the Lithium Valley, you just got where it says the 0.5C battery, but the discharge is 100 amps. So, for example, the battery is a 1C battery.
No, so the battery is 1C. The maximum discharge on this line is 100 amp, which is 100 times 50. That gives you 5,000, which is 5 kilowatt. So the C rating is this one. Then this line where it says 0.5, this is the testing, yeah. So when they tested the number of cycles, they get to 6,000, and they were testing using 0.5, continuously discharging 0.5 from the batteries. So this is what they are just telling us here. And what it means now, there's also a misconception of thinking that when you get to 6,000 cycles, then your battery is dead. No. When you get to 6,000 cycles now, your battery is reached end of life. End of life means you have lost more than at least 20% of your life. So if it was a 5 kilowatt, after 6,000 cycles, it's now a 4 kilowatt. You lose 20% of the capacity. So you don't gonna throw it away. That's why you see that the guarantee can be up to 20 years. On these batteries, you can be able to use it within 20 years after exceeding the 6,000 already. But now it depletes until you
You say that the warranty is at 6,000 cycles at half C, so the warranty isn't at 1C.
The warranty condition. This is the cycle life. It's not the warranty. So the warranty is at 1C. With the warranty documents, you can share them with you so that
you can run it at 6,000 cycles at 1C for that full warranty.
Yes, you can run it at 1C. Even the depth of discharge, you can run it up to, let's say, 95%. So you are not limited to this 8%. Yeah. But what we are doing now, you are decreasing your life. It's like this 25 degrees. If you run it at a high temperature, when you get to these 6,000 cycles, you may see that you don't lose 20%. You'd have lost, let's say, 35%. It's now just giving you 2.5. Yeah. Exactly. No, you still have the warranty up to the number of years. Nico?
No, that's all.
Oh, okay.
I just want to clarify that. Thanks.
Okay. Another question or addition or maybe experience? I've talked to a number of guys who actually have the systems installed in case someone thinks it's too new and they are happy. I mean, fi-
Kathy, one of the things you need to teach us is how to read a data sheet.
Oh, yeah, exactly.
Because the information on the data sheets, when you look at other products as well, is very, you misinterpret what you read so quickly. Because, you know, you look at something that says 6,000 cycles, 80% discharge, but it's actually not the warranty.
Yes.
It's just the test.
It's just life in the test, yeah. So, for instance, to give a silly example, it doesn't mean that this was at 25 degrees, but does it mean that the moment you discharge at 26 degrees, then you lose the warranty? It can't mean that. The same thing also, if you don't discharge at 0.5 C, doesn't mean that you're out of the 6,000. If you don't discharge up to 8%, let's say you're actually discharging up to 70%, it does not increase the number of cycles in terms of warranty, then it does not, if you also exceed the 80%, it does not decrease the number of cycles. So the cycles is to say, when they were running this test in the life cycle, these were test conditions. But you still have your 5,000, your 6,000 cycles. That's why now they come in and also give you number of years. So they can say 6,000, 10 years, whatever comes first, or 6,000, 5 years. I'm sure we need maybe Ron to confirm the warranty in terms of years, whatever comes first. So let's say you are not discharging your battery, you are just doing half 1 to half C. But when you reach those number of years, okay, you are no longer covered under warranty. Then if it's a 10-year warranty, the first 5 years is actually product warranty. Then the last 5 years is the performance warranty. To be performance warranty, they can actually say if it's not performing within that, you can initiate the RMA process. The warranty, you can claim on warranty and say, guys, my battery is not giving me the full 5,000 watt hour. Now I can only have 4 kilowatt hour. Then now you can claim a warranty if it's not performing within expectations. But after 10 years or after these 6,000 cycles, if you have lost 20%, between 20 and 35%, you can't claim because that's normal. After these cycles, now you are expected to lose that much. What?
I said they should be showing us degradation for that test as well. I mean, they've given us the criteria for the test, but they're not showing us the loss at the end of that test.
Yeah, so it's specified in the warranty document. Unfortunately, it's not on the data sheet. So in the warranty document, they're actually telling you that after 6,000 cycles, they lost 21. They lost 20.
That rate.
At that rate, they lost 21% of the capacity. But still, your battery is working fine. But whereas it could last for, let's say, if you were taking 1 kilowatt from this, it would last for 5 hours. Now, after the 6,000 cycles, it will be 4 hours. But still, your battery is going until now you lose all of that, or until maybe you lose, let's say, 60%. Then it becomes useless to you. You take it off, or you dispose it somehow. Yeah. So yeah, I think it's an important subject. When you reach, it's a chemical. The lithium valley, which is the lithium batteries, which is using lithium technology. It's a chemical reaction. Right? So those reactions, a series of those reactions, they are reducing the quality of the power that will be produced from that reaction as a result of that reaction. But it's not a binary switch where after 6,000 cycles, boom, then you can't use the battery. You can still use it, but unfortunately, the degradation is such a way that you lose the capacity of the battery. Another question, maybe before we can come closer. It was my wish, someone requested that he wants to see how we can dismantle this, then you put it together and to plug in the MC4s. Then also here, you can come closer, then you see the FNO connectors. You can open it up, then you feel and see the HMI, and you also get an opportunity maybe to play around with the HMI and go through the settings. I mean, anyone who is interested, we have got 50 or so minutes, or maybe Ron, you want to take over and say something? Okay, all right.
Because for those of you who are here, we will make sure that you've registered.
Then while you still are still on that, if the 50 minutes that we have, I understand you can't have an early lunch. If you want to look at we've got the commercial session, want to break, but if you want to look at like the Incombi or just to touch base on the other system that we have, if we think that maybe that's more helpful, Ron, I think we can guide us on that.
Okay.
All right.